So let's start by making a grid. I'm going to use P5.js for this because I can easily draw shapes, but you can use whatever you want. Create a variable for the grid size and another for the size of each tile in the grid. I'll initialize the grid size to 15, meaning the grid will have 15 tiles across the width and the height. We'll set the tile size down in the setup function. I'll make the canvas in P5.js 500 by 500 pixels. This is kind of like your window of drawing, and anything outside this window won't show. The tile size will be 500 divided by the number of tiles on the width and height, which is just the grid size variable. This makes all the tiles the right size so they fit perfectly inside the canvas and don't get cut off or leave extra space. Now you're not going to actually have a grid yet because this is just a pixel art visualization, so let's make one. In the draw function, create two loops, one nested inside the other, that go through each coordinate in the grid and spawn a rectangle at the position x, y. Both the width and the height will be tile size. There is a problem with this though, and it's that each tile's position won't take into account the size of the tile. For example, look at the tiles at this size. They seem to fit, but as soon as we increase the size of the tiles, they don't actually move to make space for the other tiles. To fix this, just multiply the x and y coordinates by the tile size, which makes sure the necessary offset is in place. Now we have a grid, but to make a radial gradient, we need to first find the center of it, which is the center of the grid. Make two variables for the center on the x-axis and the center on the y-axis. Initialize both of them as the grid size divided by 2 and floor the result to make sure it's rounded, just in case you get a decimal. Now what we're going to do is get the distance between every single tile and the center and calculate how bright that tile is based on that value. Create a function called calculateBrightness, which takes in the parameters x and y. First, find the distance from the tile to the center using the distance formula, which is just derived from the Pythagorean theorem. This is how it looks in code. Then we want to normalize the distance to a range of 0 to 1, and we do this by dividing the distance by half of the grid size. Why half? Because half of the grid size is the maximum distance that a point in the circle of the gradient can be from the center. In other words, it's the radius of the circle. So if the distance from the center is 1 and the radius of the circle is 2, then we get 0.5 as the brightness value, which makes sense because the tile is halfway through the gradient. But there are values that lie outside the circle that are going to have distances greater than the radius, meaning brightness values greater than 1. So let's just clamp this whole thing between 0 and 1 as well. Finally, return the brightness value. You might also want to multiply this by 255 because many languages use color values between 0 and 255 instead of 0 and 1. Right before drawing the rectangle, let's set the fill color to the return value of the calculateBrightness function, passing in the current x and y coordinates being iterated. P5.js lets me put in just one value for color, but other programs might require you to put in 3 values for the red, green, and blue color channels. If yours does, just copy this value for all 3 arguments. And now if you run, you should have a radial gradient. But I want mine to go from dark to light instead of light to dark, so let's add another parameter called invert. Right before we return the value, if invert is true, then set the brightness value to 1 minus itself to, well, invert it. And when you call the function below, add the new argument as true. Once you run, the gradient should go from dark to light. But gradients aren't only useful for decoration, there's so much more you can do with them. For example, you can put the brightness value through a function to make the gradient ease in or ease out, like I did here by putting it through a simple Bezier curve. Or you could add a slight bit of noise to each tile to have some variation. And you can also use this as a height map. If you create a 3D scene in a game engine like Unity, you can raise the vertices of a mesh depending on the brightness of a tile, and then you can easily get a valley or a hill shape. If it looks too uniform, just add some noise or pass the brightness value through a function. This approach doesn't just give you random terrain, but also a bit more freedom and control over it, like being able to have a hill. Or maybe you could treat this as a population density map to generate a city, spawning different types of buildings depending on the density of the tile they're on. There's so much more you can do with gradients, so keep trying out new things, and if you find something cool, I'd love to know down in the comments.